Hi everyone, my name is Wendy Fresh, and we're going to talk about degree angles in this section. So let's begin with the definition of an angle. An angle is the union of two rays having a common endpoint. But what are two rays? Well, a ray is a directed line segment that consists of one point on a line, and that point is called an endpoint, and it extends in just one direction. So the difference between a ray and a line would extend in both directions. A ray is only extending in one direction. The common endpoint of the two rays that form the angle is called the vertex of the angle, and the two rays are the sides. So those rays become the sides of the angles. Now in trigonometry, Greek letters are often used to describe the angles, and I bet you know some of the more common ones. Let's see. So the first one looks like an O with a squiggly line through it. That is the Greek letter theta. The next one I think looks like an A, and it is the Greek letter alpha. And the next one looks like a B, and it is the Greek letter beta. So theta, alpha, and beta. As the rays of an angle open, the ray that remains in a fixed position is called the initial side. We can see that down at the positive x-axis. And the ray that rotates open is called the terminal side. Now, if an angle is in standard position, then its vertex is located at the origin, and its initial side extends along that positive x-axis. So that's what we have here. If the angle is measured in a counterclockwise direction, from the initial side to the terminal side, then the angle is said to be a positive angle. So I hope that you saw that starting at the initial side, and we saw that angle open counterclockwise. If the angle is measured in a clockwise direction, from the initial side to the terminal side, now the angle is said to be a negative angle. So the only difference between a positive and a negative angle is the way they rotate. They're both beginning at the initial side. They both have their vertex at the origin. This is all if it's in standard position. A positive angle starts on that initial side and it opens up counterclockwise. And the negative angle also starts at the initial side with its vertex at the origin, but this one opens down and is in a clockwise position, same way that a clock would open up. So let's get a little bit more specific. One complete revolution produces an angle of 360 degrees, or a full rotation around a circle. So in the circle that we have here, that circle is placed on an XY axis, and it is beginning its initial side on that positive x-axis. It's opening up and it's going counterclockwise, which is what makes it a positive angle measure of 360 degrees. And it's going all the way around so that the terminal side and the initial side meet. That is a 360 degree complete rotation. But of course, maybe we aren't going to go all the way around, and that's where partial angle measures come into play. Partial angle measures are where our fraction work is going to happen, and we'll be doing lots of examples so that you can maybe refresh your memory. 90 degrees represents 90 degrees out of a total 360 degrees. If we reduce that fraction, not only does 90 over 360 reduce, but also the degree units cancel out. That leaves us with 1/4 of a full rotation. So 1/4 of that complete circle that we saw puts us in the first quadrant. 180 degrees would represent 180 out of 360 degrees. Again, the degree units cancel, and the fraction reduces to 1/2 of a full rotation. 1/2 of a full rotation around a circle takes us through not only quadrant 1, but also quadrant 2. 270 degrees represents 270 out of 360 degrees, which is 3/4 of a full rotation when we reduce, and takes us through not only quadrant 1, but also quadrant 2 and quadrant 3. Going all the way through to quadrant 4 is what our full rotation of 360 degrees is. Now, there's a special word for these angle measures that terminate on an axis. Any angle that has its terminal side actually on an axis, which were the 0 degrees, 90, 180, 270, or 360 degrees, are called quadrantal angles. So all that entails are angle measures that terminate. In this case, for the 90, that was on the positive y-axis. For the 180, that was on the negative x-axis. For 270 degrees, that is on the negative y-axis. And of course, the 360 degrees we saw terminate on the positive x-axis. Those are all on axes. They're not terminating somewhere in the middle of a quadrant. Now let's look at an example. Sketch an angle of 240 degrees in standard position. So 240 degrees in standard position. The standard position part tells me that I need to be starting with my initial side on the positive x-axis. So there we go. And the fact that it's a positive 240 degrees tells me that that initial side is going to open up and it's going to go counterclockwise. Now, where is it going to stop? Well, this is where maybe marking the circle will come in handy. We learned before that when we terminate on the positive y-axis, that is where 90 degrees is at. And if I just keep marking those angles that we identified a minute ago, then we have starting at 0 degrees, going to 90 degrees, 180 degrees, 270 degrees, and 360 degrees. 240 degrees is going to go through the first quadrant, through the second quadrant, and it looks like it's going to go about 60 degrees beyond that second quadrant, having it end its terminal side in the third quadrant. So this angle in the third quadrant is 240 degrees. Part B says to do the same thing, sketch an angle in standard position, but notice this time that angle is negative. So the difference is I'm going to start in the same location, but now I'm going to go, let me change colors, I'm going to go clockwise. So I'm going to go this direction. Negative 60 degrees is not very far into the fourth quadrant. In fact, if 90 degrees puts us up in the first quadrant, then 270 degrees could also be called negative 90 degrees. So negative 60 degrees is just going to end somewhere about right here in that fourth quadrant. If you want to see more examples of positive and negative degree measures, I've got a GeoGebra link down there at the bottom to check out.